Hello friends, welcome to Raja's Data Engineering. In this video, I am going to talk about interview questions. I keep on getting requests from many subscribers to post video regarding list of possible interview questions across Spark and Databricks. So I have decided to create a series of videos just to post interview questions. So I have divided this series into multiple sections. In one video, I will cover the interview questions related to Spark or Databricks core concepts or architectural concepts. In another video, I will talk about the questions related to performance optimization. In another video, I can talk about all the questions related to Delta Lake. In another video, I can talk about all the possible questions related to programming in Databricks and Spark. Maybe in some other video, I can talk about the possible questions related to real-time scenarios. So I have decided to post many videos just only for interview questions, and I have divided that into multiple categories. This is going to be our first video. In this video, I'm going to cover all the possible questions from Spark Databricks core concepts. Let's get started. Moving on to the first question. What is MPP architecture in big data processing? This is one of the common question not only for Spark or Databricks but for most of the big data platforms. Spark and Databricks both are big data platform. That is the reason we can expect this question in any Spark or Databricks interview. What is MPP? So in most of the questions in this video might deserve separate video, but I'm not I if needed I can create separate video, but in this video I'm not going to dive into details for each of these questions. I will just give high level direction how we have to answer. So mostly I'm going to focus only the questions on these videos, and also I will give just high level answer, but in case you want more information, just put it in the comment so that I can create a separate video. And if you have a better answer for these questions, I recommend you to put it in the comment section so that everyone can be benefited. Right, coming to the first question, what is MPP architecture in big data processing? So we have to start like MPP stands for massively parallel processing. And what is MPP? MPP is one of the big data computing architecture. We might have heard about the architecture for different solutions, but coming to MPP, that is the one of the architecture for computing platform, which means in case we have to process huge amount of data, then MPP will split the huge amount of data into multiple partitions. Then it will distribute the data across multiple nodes. Each node will contain multiple cores. So each core will start processing certain partition in parallel. So with the help of MPP, we can process huge amount of data. Without having this computing architecture, it is not possible to process huge amount of data. So this is what we have to focus in our answer. Moving to the next question, can you compare Hadoop versus Spark? And why Spark is better than Hadoop? This is also one of the basic questions that is being asked in most of the Spark interview questions. Because Hadoop and Spark both are big data platforms. While we have Hadoop in place, why do we need Spark? So that is the basic question. And interviewer wants to understand your knowledge across Hadoop and Spark. So for this question, first of all, we have to talk about the differences between architecture in Hadoop and Spark. Coming to Hadoop, we are calling that as data node, name node, and cluster manager. Coming to Spark, we call it as driver, worker, executors. And if possible, we can dive into details also on those concepts. What is data node? What is name node? What is driver? What is executor? Now, those internal architecture concept we can talk. Apart from that, we have to mention about the performance, speed. Spark is at least 10 times faster than Hadoop. In most of the use cases, it is 100 times faster than Hadoop. So we can talk about that. And what is the reason for that? Hadoop, that is following the computing model of in-disk processing. But coming to Spark, that is working in the concept of in-memory processing. So the intermediate results that are not going to be written into disk. Instead of that, in Spark, it is going to be kept in the memory. So that is the reason for speed and ease of use. Coming to Hadoop, that is using the programming language MapReduce. That is verbose and hard to understand, difficult to maintain. But coming to Spark, it is providing different programming languages like SQL, Python, Scala, R. So that's the reason, when developers coming from different backgrounds, they can easily start developing solution in Spark. And the last one, batch versus streaming. Hadoop, that is more suitable for batch processing, but coming to Spark, that is suitable for both batch and streaming. Moving on to the next question, how Spark programming differs from MapReduce. Now for that we have to talk about programming model. Coming to programming model, in MapReduce, basically it is divided into two phases, two stages. One is map stage, then the next one is reduce. And also we have to talk about the language. MapReduce, that is more verbose, difficult to understand. But coming to Spark, Spark programming, that is easy to understand, easy to maintain. Coming to speed, we already talked about speed. MapReduce, that is going to write the intermediate results into the disk. The subsequent intermediate process will read the data from disk. So it's going to be slower. But coming to Spark, it's going to be faster because it is going to keep all the intermediate results within the memory. And coming to iterative and interactive analytics, Hadoop, that is MapReduce, that is majorly suitable for batch processing. So in between, we cannot perform any interactive analysis. But coming to Spark, we can perform the interactive analytics. And also we can talk about ecosystem, component. Right. Moving on to the next question, how Databricks is different from Spark. This is also one of the basic question. Most of the developer, they used to confuse. Spark, Databricks, both are same. Even though they both, both look same. Spark, that is nothing but open source product, and Databricks, that is the licensed product. And Spark, it can be on premises, but the Databricks, that is cloud. The core Spark developers now formed a team and they created a solution of Databricks. So while explaining the difference between these two, first we have to start with unified analytics engine versus unified analytics platform. Coming to Spark, it's nothing but unified analytics engine. It can support the streaming use cases, it can support batch use cases, and also it can support multiple different APIs like DataFrame, DataSet, RDD, and also it can support multiple programming languages. So Spark is unified analytics engine. But coming to Databricks, it is suitable for collaboration. Within that Databricks cloud-based workspace, many developers can collaborate as a team, and in single place, we can perform a lot of different operations. Like we can use SQL endpoints, we can use machine learning related operations. We can do access management, we can manage the clusters, we can do a lot of things. That's the reason this is called unified analytics platform. And like collaboration, Databricks, that is more suitable for collaboration, but Spark is not. Coming to performance, we know Spark is faster because of in-memory processing, but still there are many bottlenecks within the Spark. As Databricks developers are coming from a Spark background, they know the bottlenecks of Spark. So they have created runtime, Databricks runtime. Within that, they have done a lot of performance improvement. So that's the reason is 10 times faster than Spark. And the next point, Databricks, that is a managed service. Spark, that's a open source. And in Databricks, the cluster management is automated, but coming to Spark, it's not automated. We need to deploy separate team for cluster management. And also in Databricks, we are having many additional features like auto loader. Even open source Spark, in order to display the output, we have to use a show command. But coming to Databricks, along with show, we can also use display. There are different additional functionalities given by Databricks. These are the major differences between Databricks and Spark. Coming to the next question, can you talk about memory management in Spark? For this question, we have to talk more about on-keep and off-keep memory. I have already posted a video about this. In my playlist, in my video series, you can see the video number 4. That is talking more about memory management. And along with memory management, we can also talk about garbage collection and also performance. Which is better, on-keep or off-keep memory. For which scenario we can go with on-keep. For which scenario we can enable off-keep. And what is the memory fraction within on-keep memory? We are having user memory, storage memory, execution memory. We are having different memory fraction. So I have talked about all those parameters in this video, so you can watch this video. And moving on to the next question, what are different types of clusters in Databricks? Can you elaborate more on those types of clusters? In Databricks, we are having two different types of clusters. One is all-purpose cluster, second one is job cluster. Apart from that, we are also having cluster pool. But coming to types of cluster, it's only two, all-purpose and job cluster. All-purpose cluster, that is more suitable for development and also ad hoc analysis. Coming to job cluster, that is more suitable for production deployment. Moving on to the next question, what is the difference between client mode and cluster mode while deploying Spark applications? Now, these are the different yeah, modes while deploying Spark application. The first one, client mode, which means the driver program that is running in the client machine. Okay, the client machine from where we are submitting the Spark application, in the same machine, driver program will be running. But coming to cluster mode, the driver program would be running in the cluster itself, in the driver node. So that is the major difference. And coming to client mode, driver program would be running in the client machine, but Spark runtime and related dependencies, those will also be installed in the client machine. Coming to use cases, client mode that is more suitable for development and interaction. Cluster mode that is more suitable for production. And the next question is, what is cluster manager? Cluster manager, that is the mediator between a driver program and executors. So whenever Spark application is submitted to the cluster, then driver will understand the program, then it will optimize, then it will split the task into jobs, stages, a task. Then finally it has to be executed in the executor. For that, a driver will contact a cluster manager, and cluster manager is responsible to assign list of executors to the driver. Then driver will immediately coordinate with those executors. Then it will assign the task so that executors can execute that task. And cluster manager that is responsible fault tolerance, because whenever there is a particular node that is dead, cluster manager will keep on sending heartbeat signals to all the worker nodes, and if there is no response from one of the worker node, it means it's dead. Then cluster manager is responsible to replace that worker node, and also it will recreate the partitions that are stored within that particular node. So that cluster manager plays important role in the fault tolerance. Right, and coming to types of cluster managers, we are having different types like standalone cluster manager, Mesos, Yarn cluster manager. These are the different cluster managers. Now, these are the topics we can cover for this question. Moving on to the next question. Now, this is also one of the very common question in most of the interviews. What is the difference between Spark session and Spark context? Coming to Spark context, that was the entry point for any Spark application before Spark version 2.0. But starting from Spark version 2.0, it is called Spark session, because Spark session, it is unified entry point, which means Spark session that is containing multiple context, not only Spark context, it is also having SQL context, streaming context, graph context. It is combining multiple context as a packaged one, so that it is called as Spark session. So here we have to talk about the version, before 2.0 it is Spark context, after 2.0 it is Spark session, and also Spark session that is a unified entry point. And also in Spark session, it is supporting multiple languages like R, Scala, Java, Python, SQL, and also it is supporting different APIs like RDD, DataSet, DataFrame. Yeah, these are the major points we need to cover for this question. Moving on to the next one, how parallelism is achieved in Spark. So this is one of the generic question. As long as we have a good understanding of MPP, then we can answer to this question. Here we have to talk about data split and distribution. Whenever Spark application is submitted, then based on driver instruction, executor will connect the source systems, then it will pull the data in the form of partition, then that is being distributed across multiple nodes. Then the number of cores within each executor will start processing one particular partition. So in this way, we are achieving parallelism. And here we can talk about lazy evaluation also. A Spark that is working in the concept of lazy evaluation, which means whenever we are submitting certain transformation, it is not going to be executed immediately. Instead of that, a lineage graph will be built. When the Spark engine encounters a certain action, then only that particular action along with all the previous transformations will be packaged together and that will be executed. And that execution will happen in parallel. This is what we need to focus for this question. Moving on to the next question, can you talk about the differences between RDD, DataFrame, and DataSet? These are the different APIs used within Spark environment. I have already posted a video about that. This is video number 2 in my video series. In case you haven't watched this video, you can watch. So here, basically we have to talk about these parameters. The first one, user friendliness. Coming to RDD, now that is the native API for Spark, but still it is not user friendly. Because we have to write verbose code. Lot of code, that is difficult to understand and maintain. But coming to DataFrame, it's a SQL like language, so it's very easy to understand and maintain. And coming to performance, DataFrame is better in terms of performance because DataFrame, it's having schema, it's a structured data. As a result, Catalyst Optimizer can optimize the execution plan. And coming to RDD, we have to write the code in verbose, so we have to tell how to do. In order to achieve certain output, we have to give lot of instruction how to do. But coming to DataFrame, we can simply write a code what to do. Then Spark engine will understand internally, then it will come up with outcome. And coming to languages, RDD and DataFrame, both are supporting all the languages that we discussed earlier. R programming, Scala, Python, SQL. But coming to dataset, this is supporting currently only R and Scala. And also we can talk about on-keep and off-keep memory. In RDD, that is only on-keep memory. So there is no option of off-keep memory. But coming to DataFrame and dataset, we can enable off-keep memory also so that we can minimize the garbage collection scanning. These are the important points we need to talk about for this question. And moving on to the next question, what is transformation and action in Spark? So for this question, I have already posted a video, that is video number 3. In case you haven't watched, you can watch. But coming to answer, first we have to talk about immutability in Spark, which means whenever we are transforming one of the RDD or data frame, it is always creating new data set, new data frame or RDD. So that is immutable. And also here we need to talk about lazy evaluation and tag. Lazy evaluation, as I mentioned earlier, in Spark, whenever we are giving certain transformation, it is not going to be executed immediately. Instead of that, it is going to create lineage graph in the form of a tag that we need to talk about. And the basic answer transformation, that is nothing but basically it is transforming the data set or data frame or RDD from one form to another form. So that is transforming, which means it's not actually changing the existing one. So whenever we are applying transformation, it is going to create new RDD or data frame or data set. And also for transformation, we can talk about narrow and wide. And also we can talk about examples like join, group by, those things. Coming to action, as soon as the output is needed for one of the logic in the Spark application, like the output is needed for user or the output needs to be written into some storage, then that is called action. Then whenever there is an action, then Spark will start executing all these previous transformations along with this action. So coming to transformation, that is lazy evaluation. Coming to action, that is eager evaluation. And we can talk about some examples in action like write operation and collect, take. These are the different examples for action. Moving on to the next question, what is lazy evaluation and why it is important? This is one of the important question, and it's very very important to understand what is lazy evaluation and what is the role it is playing in Spark execution. So lazy evaluation, this is one of the performance improvement method given by Spark. Let's say we are giving a list of instructions. Let's say we are giving some calculation on top of millions of records. After that, we are going to apply some filter. That filter, it is going to retrieve only 1,000 records out of million or billions of records. So first we applied certain logic, then second we are filtering. So that is not right approach. So as a human, as a developer, we can give these kind of instruction. In case we don't have lazy evaluation in place, then what happens is, first of all, that logic will be executed on top of billions of records. Then finally filter will be applied, which will just retrieve only 1,000 record. That is not the right approach. Instead of that, if you are going to reverse that approach, first filter only 1,000 records, then apply the logic on top of those 1,000 records. It's going to be super fast. So that is the advantage of lazy evaluation. So we have to just give list of transformations. Spark will keep on receiving all the transformations, and it will keep on building lineage graph. Then finally, whenever we are giving some action, then Spark engine will decide which operation it has to execute first, which operation it can execute later, so that it can get the same output with less effort. So this is one of the performance optimization method. This is what we need to talk about for this question. And coming to points, this is lazy evaluation. That is one of the strategy to defer execution. And this is providing optimization opportunities, and also it is doing only selective computation, like it will do predicate push down, projection push down, these kind of operations it will perform. And also this is key for fault tolerance. Based on the lineage graph, based on the lazy evaluation, we will be able to recreate any data set or data frame. And also it is leading to reduced resource overhead. As I told earlier, it is going to optimize the query. As a result, we don't need to use a lot of resources for the execution. Moving on to the next question, what is tag? What is lineage graph? Now this stands for directed acyclic graph. This is useful in lineage tracking. And in the graph, we are going to keep all the transformations as a node and the dependency as edges. And this is playing important role in lazy evaluation. And using this tag, we can recreate any data set. So it plays important role in fault tolerance also. And based on the tag, execution plan will be generated by the driver. These are the different points we can talk about for this question. Moving on to the next question, what do you mean by immutability in Spark, and what is the advantage of that? For this one, I already talked about this one. This is also one of the generic question. So immutability, which means APIs cannot be modified within the Spark, which means, let's say we are having a data frame or RDD, we are applying certain transformation on top of that, which means it is not going to modify the existing data frame. So it is always going to create a new data frame on top of the applied logic. So that is called immutability. And what is the advantage of that? It is immutable. So that's the reason, the execution is always deterministic, and it's predictable. So if there is any failure, then easily the data set or data frame can be recreated with the help of lineage graph. And this is also performing important role in the performance optimization. Now these are the points we need to talk for immutability. And the next question, that is one of the very common, very generic in most of the interviews you can expect. Can you talk about Spark architecture? We can talk about architecture for many hours, but depending on the expectation of the interviewer, we can cover only the high level, the major points. And interviewer is allowing more time, then only we can dive into details, and we can talk more about Spark internal architecture. I have already posted a video about Spark internal architecture. In case you haven't watched, I highly recommend to watch that video. That is the video number 1. So for this question, majorly we need to talk about driver, worker, and executor. And also we have to talk about the Spark session. We can talk about partition and shuffling, how we know the partitions are created, how shuffling is working. And we can also talk about memory management. We can talk about lazy evaluation. Also we can talk about the execution hierarchy, execution blueprint, jobs, stages, task. Now these are the topics we can cover for this question. Moving on to the next one, what is the difference between driver, worker, and executor? This is also one of the common question. As long as you have good understanding about Spark internal architecture, then you will be able to answer. So driver, that is a mastermind. So whenever we are submitting some application, first it goes to driver. Driver keep on creating a lineage graph, and when there is an action, then it is converting the lineage graph into execution plan. Then it is connecting with the executors. Then it is getting the task done. This is what we have to talk about driver. Coming to worker, that is nothing but part of cluster. Worker, it's a separate node. So each worker that is logically divided into multiple executors. It could be one executor or more than one executor, that we can talk about. And coming to executor, that is the computing engine which is responsible to execute the task assigned by driver. So each executor will contain on heap memory and also number of cores. And driver and executor, these are nothing but JVM process, Java virtual machine. And cluster manager is the mediator between driver and workers. Right, moving on to the next question. How partitions created in Spark? I have recently posted one video about how partitions are created within Spark. Whenever we are submitting certain application, let's say we have to read CSV file from external storage like Azure Data Lake Storage or S3 bucket. Then we are giving Spark dot read dot format CSV dot load. We are giving that particular location. Then actually how partitions are created from the external system, and how it is stored within a Spark environment. So for that I have already posted a video. It's one of the good video. I highly recommend to watch that in case you want to understand the internal mechanism of partition creation. So basically here we need to talk about the parameters which are affecting the number of partition, like number of cores, maximum partition bytes plus open cost in bytes. And also there are various components involved in creating the partitions, like file input format, input split, record reader. And the Spark engine will calculate these parameters in order to create the partitions. It will calculate bytes per core, maximum split bytes. Based on that, it will logically divide the data. Then it will do the partition packing in order to create the final partition. So we can talk about these points for this question. Moving on to the next one, what is shuffling in Spark processing? So this is also one of the generic and basic question. The interviewer would like to understand your understanding in Spark shuffling. So for that, we have to talk like shuffling is nothing but one of the Spark fundamental operation of redistribution or reorganization of partitions. Whenever there is a wide transformation, then new stage would be created. As a result, data would be shuffled. The examples are like group by operation, any aggregate operation, join, order by. These are the examples of shuffling process. Moving on to the next question, what is the difference between narrow transformation and wide transformation? This is also one of the common question. I have already posted a video about the transformation and action. If you understand that video, then you will be able to answer this question easily. So coming to transformation, it is always going to create new RDD or data frame. And coming to narrow transformation, there is no shuffle. There is no shuffle needed. In order to apply certain logic, all the required data is available within each partition. So one particular calculation that is not depending on multiple partitions. So there is no partition dependency. As a result, it will perform better. So the examples are filter union. Coming to wide transformation, it would require shuffle. So it means whenever we have to apply certain logic, then the output that is depending on that calculation, that is depending on multiple partitions, which means there is partition dependency. The examples are join, group by, sorting. These are the examples of wide transformation. So we need to cover these points for this question. Moving on to the next question, what are jobs, stages, task? So these are nothing but Spark application execution hierarchy, or we can say blueprint. So whenever there is an action in the Spark application, then driver will start executing. It will start creating the execution plan. Based on that, it will divide the entire operation into jobs, stages, and task. So job, that is nothing but whenever the Spark engine has to touch the data in the external storage or in the partition in the RAM, then it has to create new jobs. And whenever there is a shuffle, whenever one calculation depending on multiple partitions, then it would need shuffle. So whenever there is a shuffle, new stages will be created. And coming to task, how many partitions are created for a Spark application, based on that those many number of tasks could be created, and all the tasks will execute the same logic at a time. This is the expected answer. So we can cover these points for this question. Moving on to the next one, what are the big data file formats? So we are working, we are dealing with a huge amount of data in Spark and Databricks. So basically we are dealing with big data file formats. So the file formats like Parquet, Avro, ORC, CSV, JSON, these are the different file formats. And the interviewer might like to get some information about your project. So in your project, what are the different file formats you are using, and for which use case you are using which file format. Now that is the expectation. So you can talk from your project point of view. Moving on to the next question, what is the difference between Parquet and Avro? This is also one of the very common interview question in most of the big data or Spark Databricks interviews. So coming to Parquet and Avro, we have to talk about analytical versus transactions. Parquet, that is the read heavy operation. So that is more suitable for analytical process. Write it once and read many times. So Parquet, that is more suitable for OLAP, data warehousing related use cases. Coming to Avro, this is a row based column, but Parquet, that is a column based one. Avro, that is row based, so that's the reason that is more suitable for editing the data, which means that is more suitable for transactions, which means databases or OLDP related use cases. And the format, Parquet, that is a columnar, Avro, that is row based. And coming to Parquet, that is working in the concept of warm, which means write once, read multiple times. And Parquet, that is giving better compression, and also it is performing better because of this column pruning, and that is more suitable for read heavy process. And the Parquet, that is immutable in nature. Coming to Avro, that is more suitable for write heavy process. This is supporting schema evaluation, and Avro, that is highly splittable, and the schema for Avro is stored in the form of JSON, that is human readable. Now these are the major differences we can talk about for this question. Moving on to the next one, this is one of the basic question. What are the different programming languages supported by Spark? Here we can talk about SQL, Python or Scala. And in your project, for which use case, for which scenario, you are using which language, that you can elaborate more on this question. Right, moving on to the last question, what is Catalyst Optimizer? I have already posted one video, the video number 24. Here I have given detailed explanation for Catalyst Optimizer. In case you haven't watched, you can watch so that you can answer in a better way. So Catalyst Optimizer, that is one of the performance optimization for DF, because it is understanding the data frame code. Based on that, it is creating unresolved logical plan. Then based on that, it is converting the logical plan based on the schema. Then it is doing optimized logical plan, which means it is doing predicate boost down, projection boost down, and it is rearranging the filter. It is reusing Java function. Now these kind of operations it is doing in the optimized logical plan. Then finally it is converting the optimized logical plan into physical plan. Then it is applying the cost model. Based on the cost model, it is choosing the plan which is very low cost. So we need to talk about these points for Catalyst Optimizer. And if you have time, then we can talk about rule-based optimizer and cost-based optimizer. These are the different points we need to talk for Catalyst Optimizer. So these are the most commonly asked 25 questions for Spark and Databricks interviews. I hope you understood. I hope you can answer effectively. But in case you want any detailed answer, you can ask me in the comment so that I can create separate video for that particular question. And also if you have better answer for any of the question, put it in the comment section so that everyone can be benefited. I hope you enjoyed this video. Hope you liked it. If you like the content of this video, please like and comment in the channel Also subscribe this channel. Don't forget to click on the bell button to get the latest videos on Spark and Databricks. Thank you.